Q. A body covers displacement of 10 meters towards north and returns back to initial point by covering 10 meters towards south. Its total displacement is A. 20 meters north, B. 10 meters south, C. CRM along north-south, D. OM. ANS. OM along north-south. Q. The unit of the kinetic energy is same as that of A. Momentum, B. Velocity, C. Force, D. Work. ANS. Work. Q. Which one is not a vector quantity? A. Angular displacement, B. Impulse, C. Moment of inertia, D. Momentum. ANS. Moment of inertia. Q. In Newton's first law of motion, which quantity remains constant? A. Velocity, B. Angular displacement, C. Amount of work, D. Amplitude. ANS. Velocity. Q. Law of inertia satisfies A. Condition of equilibrium, B. Condition of variable force, C. Condition of force in contact, D. Condition of conservation of mass. ANS. Condition of equilibrium. Q. When 5 times momentum of a body is equal to the kinetic energy of the same body, then its velocity is equal to A. 5 ms, B. 10 meters per second, C. 15 ms, D. 20 meters per second. ANS. 10 meters per second. Q. When angular speed of a body is doubled, the centripetal acceleration becomes A. Doubled, B. Thrice, C. 4 times, D. Remains the same. ANS. 4 times. Q. A projectile is launched. Its velocity is maximum at A. Point of projection, B. Highest point, C. Between launching and highest point, D. All points. ANS. Point of projection. Q. The equation for kinetic energy is A. K equals P to mB, K equals 1 to mVv, C. K equals 1 to mv effect D, E equals m1 to Vw. ANS. K equals 1 to mVv. Q. 2 bodies A and B of temperatures T equals 1 OOC and TOC are brought in thermal contact with each other. Which one in the following is possible at thermal equilibrium? A. TA equals OC, TS1 OCB, TA equals 60C, T equals 50C. C. TA equals 45C, TS equals 45CD, TA equals 60C, T40C. ANS. TA equals 45C, TS equals 45C. Q. In an isolated thermodynamic system. A. No heat transfers to the environment. B. Neither heat nor any mass are transferred to the environment. C. No dissipated energy and heat are transferred to the environment. D. No mass transfers to the environment. ANS. Neither heat nor any mass are transferred to the environment. Q. The energy stored in a capacitor is given by A. U equals 1 to QV2, B. U equals 1 to CV2, C. U equals 1 to QC, D. U equals Q to V. A and S. U equals QV2. Q, two charges, one of which is Q equals 3C and second one is C equals 1 UCR, separated by 100 centimeters. The electric potential is 0 at a point A. 25 centimeters from Q2, B. 75 centimeters from Q2, C. 50 centimeters from Q2, D. 33.3 centimeters from Q2. A and S, 25 centimeters from Q2. Q. Magnetic lines of force are A. Imaginary lines which show actual magnetic field. B. Actual lines which show actual magnetic field. C. Imaginary lines which show imaginary magnetic field. D. Actual lines which show imaginary magnetic field. A and S, imaginary lines which show actual magnetic field. Q. Potential divider circuit is made when A. Current is divided, B. EMF source is divided, C. Resistance is divided, D. Number of electrons are divided. A and S, resistance is divided. Q. A conductor has resistance P if its length is stretched to twice the actual value and its radius is reduced to 1/3 of its original value. The new resistance will be A. 3 RB 9 revolutions, C. 18 RD 27 revolutions. A and S, 18 revolutions. Q. Electricity consumption is calculated commercially in A. Kilowatt, B. Kilowatt hour, C. Megawatt, D. Gigawatt. A and S, kilowatt hour. Q. Two electric bulbs A and B of powers 500W and 200W, respectively, are connected to 240 volt supply. The ratio of current passing through bulb A to the current passing through bulb B is A. 1 to B, 1 to 4, C. 18D, 116. A and S, 1 to 4. Q. A conductor has length equal to meters and radius are meters. Its resistance will be equal to A. RPR B RPR, C. RPR D RPR. A and S, RPR. Q. A charged particle entered in a magnetic field antiparallel to the field. Magnetic force on this particle is A. Bino B. Bovino, C. 0D IQLV. A and S, 0. Q. When a neutron enters into a magnetic field B perpendicularly with velocity v, its acceleration is A. 0B centripetal, C. Positive, G. Uniform and non-zero. A and S, 0. Q. What is the inappropriate statement for step-up transformer? A. It increases given AC voltage. B. It decreases given alternating current. C. Heat is never produced in step-up transformer. D. Its input energy is always less than its output energy. ANS. Heat is never produced in step-up transformer. Q. When two conductors each of resistance are attached in series to external circuit, their net resistance is A. RB, SAR, C. 3RD. For revolutions. ANS, SAR. Q. An ideal AC generator has equal input and output. Its heat dissipation will be A. Of some finite value, B. 0, C. Maximum, D. Very much small. ANS, 0. Q. The unit of magnetic flux is A. Not MB, not M, C. Not MD. Tester. ANS, not M. Q. AC generator stops suddenly when A. External voltage overcomes the back EMF. B. Torque of back EMF exceeds the external torque. C. Resistance of the coil produces heat. D. Moment of inertia of the collet decreases. ANS. Torque of back EMF exceeds the external torque. Q. Output current of a half-wave rectifier is A. AC current, B. Unidirectional current, C. 0 always, G. Straight line parallel to vertical axis. ANS, unidirectional current. Q. The resistance of full-wave rectifier is A. Less than the resistance of half-wave rectifier. B. More than the resistance of half-wave rectifier. C. Equal to the resistance of half-wave rectifier. D. Negligible in comparison to the resistance of half-wave rectifier. ANS. More than the resistance of half-wave rectifier. Q. An electron will have maximum kinetic energy when it has A. Long wavelength, B. Short wavelength, C. Low frequency, D. Circular motion. ANS. Short wavelength. Q. When AC is converted to DC, the process is called A. Magnification, B. Amplification, C. Rectification, D. Resolution. ANS. Rectification. Q. In pair annihilation, two gamma-ray photons created travel in opposite direction, not in the same direction, because A. This proves law of conservation of energy. B. This proves law of conservation of momentum. C. This proves law of conservation of charge. D. This proves law of conservation of mass energy. ANS. This proves law of conservation of momentum. Q. The radiation emitted by warm-blooded animals lies in the region of A. Visible, P. Ultraviolet, C. Infrared, P. X-rays. ANS. Infrared. Q. Which photon is traveling with largest speed in vacuum? A. Gamma photon, B. Visible light photon, C. Infrared, D. All photons move with the speed of light. ANS. All photons move with the speed of light. Q. The net displacement divided by the total time t is known as A. Instantaneous velocity. B. Uniform velocity. C. Average velocity. D. Variable velocity. ANS. Average velocity. Q. The half-life of a radioactive sample predicts about A. Whole life of sample. P. Disintegration time of half number of atoms. C. Decay only. D. Total time for stable atoms. ANS. Disintegration time of half number of atoms. Q. In a conducting electric wire, the electric current flows due to A. Protons. B. Ions. C. Holes. D. Electrons. ANS. Electrons. Q. The shortest possible wavelength is associated with A. Lyman series. B. Balmer series. C. Paschen series. D. Brackett series. ANS. Lyman series. Q. Which radiation cannot be generated under electron transitions in different orbits? A. Infrared. B. Ultraviolet. C. X-rays. D. Y-rays. ANS. Y-rays. Q. Radioactivity does not depend upon A. Initial number of atoms. B. Temperature. C. Nature of material. D. Time. ANS. Temperature. Q. Which one is not the unit of radioactivity? A. BQ. D. CI. C. Decay second. D. Tester M. ANS. Tester M. Q. Curie is the unit of A. Radioactivity. B. Temperature. C. Half-life. D. Transition of magnetism. ANS. Radioactivity. Q. Which one is stable element in the followings? A. Lead. B. Plutonium. C. Radium. D. Protactinium. ANS. Lead. Q. In physics, it is observed that when matter and antimatter combine, they form A. Particles with zero charge. B. Particles with positive charge. C. Particles with negative charge. D. Particles with dual mass. ANS. Particles with zero charge. Q. The longest wavelength observed in Balmer series is A. 36R5. B. 36R7. C. 36811. D. 36R13. ANS. 36R5. Q. The shortest wavelength of Lyman series is Rydberg constant. A. RB 1R. C. 3RD 5RH. ANS. 1R. Q. For the treatment of cancer, the source of gamma rays used is A. CO60. B. Iodine 126. C. NAR15. D. PB207. ANS. CO60. Q. the velocity time graph of a motion. Starting from rest with uniform acceleration is a straight line. A. Not passing through origin. B. Parallel to time axis. C. Parallel to velocity axis. D. Passing through origin. A and S. Passing through origin. Q. A projectile is thrown at an angle of 45 with horizontal, and its range is. Like another projectile is thrown at an angle of 45 with vertical, and its range is RS. The relation between R and res. A. I equals 2RB, R equals to R. C. I equals RD. 3 revolutions are. A and S. I equals R. Q. A cyclist comes to a skidding stop in 10m. During this process, the opposing force on the cycle due to the road is 200 N. How much work does the road do on the cycle? A. 1801. B. Minus 20,001. C. 2001. D. 19,001. A and S. Minus 20,001. Q. The energy of simple harmonic oscillator at a displacement x is partly kinetic and partly potential. The total energy of a simple harmonic oscillator remains constant everywhere. Which one of the following option will be correct about the simple harmonic oscillator? A. Kinetic energy is maximum at extreme position. B. Potential energy is maximum at extreme position. C. Both kinetic and potential energies are minimum at mean position. D. Potential energy is maximum at mean position. A and S. Potential energy is maximum at extreme position. Q. The speed of a wave on a particular string is 24 ms. If the string is 6.0 meters long, to what driving frequencies will it resonate? A. 1 Hz, 2 Hz, 3 Hb, 2 Hz, 4 Hz, 6 Hz. C. 3 Hz, 6 Hz, 9 Hz. D. 5 Hz, 10 Hz, 15 Hz. A and S. To Hertz, for Hertz, 6 Hz. Q. The apparent change in the frequency of sound caused by the relative motion of either the source of sound or listener. Both is called A. Compton effect. B. Zeeman effect. C. Stark effect. D. Doppler effect. A and S. Doppler effect. Q. The time period of a simple pendulum with mass m is t when the pendulum's mass m is replaced by another ball of mass 3 times the older mass such that the length of pendulum is not changed. Then its new time period will be A. Tb 3t. C. 3t. D. 2t. A and S. T. Q. The velocity of a wave is v. Its time period is tan fis its frequency. Then the correct equation for frequency is A. T equals Vf. B. 1f equals v plus t. C. 1f equals 1t. D. T equals v or t. A and S. 1f equals 1t.